The CheapBot line follower is an inexpensive line sensor. With only 16 pieces, it can be assembled in about an hour with simple tools. The line sensor mounts to the bottom of the robot, where it monitors the surface for black and white spaces. The preferred location is below the nose of the robot and before its main drive wheels. This way, the robot can respond to changes in the black line it's trying to follow with sufficient time to react. The line follower has two pairs of black and white sensors. Each pair of sensors has an infrared light-emitting diode, or IRED, on the left. The IRED is constantly emitting a beam of infrared radiation towards the floor. On the right is a phototransistor. The robot controller monitors the voltage at the collector of the phototransistors. When a phototransistor is not conducting, the robot controller detects 5 volts. This is a logic high or a digital 1. When the phototransistor is conducting, the robot controller detects 0 volts. This is a logic low or a digital 0. Between the IRED and the phototransistor is a block of styrofoam and hot glue to maintain the proper orientation. In this example, the black line is no longer beneath the center of the robot. For whatever reason, the black line is beneath the left side of the robot. And unless the robot controller detects this, it's liable to drive off the line. Since the robot controller is monitoring the voltage of the phototransistors, it's able to detect this condition and react. Since the beam is shining on a white surface, the white surface's high albedo or reflectivity reflects the infrared radiation back up towards the line sensor. The reflected infrared beam causes the phototransistor on this side of the line follower to conduct. When it does, the robot controller detects 0 volts at the phototransistor. The logic low signals the robot controller that the black line is not beneath the right side of the robot. The situation is different for the left side of the robot. Here the infrared beam is shining on black tape. Black tape has very low albedo, and therefore it reflects very little infrared radiation back up to the line follower. Since virtually none of the infrared is reflected back to the phototransistor on this side, it doesn't conduct. The robot controller detects this as a logic high or a digital 1. The digital 1 on the right side indicates to the robot controller that the black line is beneath the right side of the robot and that it must steer to the right to avoid driving off the black line. Let's watch a CheapBot navigate a curved line of black electrician's tape. The center of the robot is positioned over the black tape before it's switched on. The program in this robot monitors the black line, and as long as it remains between the left and right detector pairs, the robot continues driving straight. If, however, the line appears below one of the sensor pairs, the robot steers in that direction to move the line back to the center of the robot. When the black line appears beneath both sides of the line followers to detectors, the robot assumes it has reached the end of its path, as marked by the T at the end, and it stops.